Hello everyone. For this tutorial video, I like to explain how you can associate vectors with electrical signals, and how vectors that represent electrical signals are called phasors, as a reference to how the direction of the vector carries phase information about the signal. In particular, if you have a simple AC waveform with only one source like this, you would represent it with a right-pointing vector with a length corresponding to the amplitude or height of the wave, measured relative to the zero level. So if you have another waveform that combines with and compares to the original waveform, you would represent it with two vectors that meet at the same endpoint, and the waveform that is behind or leads the other waveform would be drawn to the left of it, like so. Or more technically, since we are doing circles and vectors, it would be counterclockwise. Because of the fact, if we had a situation like this, the leading signal would be to the right and not to the left, so we would use the word counterclockwise to be more accurate. So now that we know the convention for representing AC signals with vectors, we can use this logic and combine multiple signals that are out of phase in one circuit like this, and represent the magnitude of them with the length of the vector, and the phase of them with the degree of the vector. However, if you are already familiar with how vectors work from trigonometry, you should already know that the magnitudes and directions do not add up as given, but have to be converted into x and y components first before adding. Where in the context of electrical engineering, the first number is usually written without a coefficient, and the second number, the y component, is written with a j. So once we do the arithmetic only after converting to x and y format, we get an answer for the exact amplitude and exact phase for the resultant. Now that I've explained how to combine multiple signals that are out of phase relative to each other, I can explain how to apply capacitors and inductors in the context of AC, as well as show more complicated circuits that use these for practical purposes, like radio broadcasting. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.